E-Classroom, sponsored by রাষ্ট্রীয় মাধ্যমিক শিক্ষা অভিযান, ত্রিপুরা রাজ্য মিশন।
মাধ্যমিক স্তরের শিক্ষার গুণগত মানকে সুনিশ্চিত করার লক্ষ্যে রাষ্ট্রীয় মাধ্যমিক শিক্ষা অভিযান, ত্রিপুরা রাজ্য মিশন কর্মরত মাধ্যমিক স্তরের শিক্ষক ও বিদ্যালয় প্রধানদের প্রশিক্ষণ, বিজ্ঞান শিক্ষণ সামগ্রী প্রদান, ছাত্রীদের আত্মরক্ষামূলক প্রশিক্ষণ, মেধায় পিছিয়ে পড়া ছাত্রছাত্রীদের বিশেষ শিক্ষাদান, প্রতিবন্ধীদের জন্য অনুদান, রাজ্যে কলা উৎসব আয়োজন সহ অন্যান্য কর্মসূচি রূপায়ণ করছে।
জানেন কি, বিদ্যালয় ছুট সারা দেশের একটি জ্বলন্ত সমস্যা। এই সমস্যা সমাধানে রাষ্ট্রীয় মাধ্যমিক শিক্ষা অভিযানের উদ্যোগে আগামী 1 জানুয়ারি থেকে সপ্তাহব্যাপী বিদ্যালয় ফিরে চলো কর্মসূচি গ্রহণ করা হয়েছে। 14 থেকে 16 বছর বয়সী সমস্ত ছেলে মেয়েদের মাধ্যমিক শিক্ষা সম্পূর্ণ করার জন্য আপনারা সবাই এগিয়ে আসুন।
মাঝপথে যারা লেখাপড়া ছেড়ে দিয়েছো বন্ধুরা, তোমরা বিদ্যালয়ে আবার ফিরে এসো।
রাষ্ট্রীয় মাধ্যমিক শিক্ষা অভিযান।
Hello students, how you all are doing? Good, sit down. The topic which we shall be discussing today is colligative properties. Colligative properties of a solution are the properties which depends on the number of solute particles only present in a definite amount of solvent and not on their nature. Now we have 4 types of colligative properties: relative lowering of vapor pressure, depression of freezing point, elevation of boiling point, and osmotic pressure. Out of these 4 colligative properties, today in this class we shall be discussing 3 colligative properties. Let us first begin with the first colligative property, that is relative lowering of vapor pressure. Before we go to the topic in detail, let me first explain you what vapor pressure is. Suppose we have a volatile solvent confined in a vessel which is covered with a lid. As the nature of the solution is volatile, the molecules in the liquid phase they are in a random tendency to go to the vapor phase. When a minimum amount of molecules in the vapor phase will be accumulated, they will go back to the solution side by the process known as condensation. As a result, there are 2 processes taking place. One is evaporation, which is responsible for transforming the molecules from the liquid state to the vapor phase, and condensation, which is responsible for converting the molecules from the gaseous phase to the liquid phase. Now, when there will be an equilibrium, the rate of evaporation will be equal to rate of condensation. The vapor exerted by the molecules in the vapor phase will be the vapor pressure of this volatile solvent. Is that clear? Now, can anyone define what is vapor pressure? Shatarupa?
In case of a volatile liquid, when equilibrium is reached between the state of evaporation and condensation, the vapor exerted by the molecules in the vapor phase is called the vapor pressure of that volatile solvent.
Very good. All of you got this point?
Yeah.
Now, what will happen if we have a solution? Means a solvent which is contaminated with a non-volatile solute. The bigger one is an example which has only the volatile solvent, and the bigger 2 is an example of solution which has solvent as well as non-volatile solute. As it is clear from the picture that the vapor pressure of the solvent is much more than that of the solution. The reason behind this is part of the surface molecule of the solution is covered by the non-volatile solute molecules, who will not take part in the process of evaporation. As well, they will not allow the molecules which are just lying below them to go to the vapor phase. As a result, at a particular temperature, the vapor pressure of the solution will be less than that of the pure solvent. In case of solution, the vapor pressure of solution is because of the vapor pressure of the solvent plus solute. Okay, in this case, the solute's contribution is 0. Okay, now suppose we have a solution. We have a solution which is made up of two components, component A and component B. Component B is non-volatile, while component A is volatile. According to Raoul's law, the vapor pressure of this solution will be the partial pressure of component A, and Raoul's law says that partial pressure of component A will be equal to the vapor pressure of the component A in its pure state, means when it was present in the beaker only, into its mole fraction. So in the next expression we shall be using this formula. Okay, is that clear?
Yes, ma'am.
So now we will be considering a solvent and a solute. This one is non-volatile solute, and this one A, component A, is volatile solvent. As because this is volatile, this part, its partial pressure will be PA and mole fraction is XA. Whereas the solute's partial pressure, it doesn't have any partial pressure because it is non-volatile in nature, but its mole fraction is XB. So the total pressure of the solution is because of PA, PB is 0. We can write it PA plus PB, but contribution from this is 0. So we will be writing only PA. The vapor pressure of the solution is because of the vapor pressure of the solvent, which is further equal to this one. We got it from Raoul's law. This XA can be written as 1 minus XB. Can I write it like this? Because we know XA plus XB equals 1. Now removing the first bracket, we will get okay. So P solution minus P0A equals minus P0A into XB. Let us multiply both the sides by minus. We will get P0A minus P solution equals P0A into XB. What does this component, this portion is said to be? This is lowering of vapor pressure. How much the vapor pressure has been lowered because of the presence of that non-volatile solute. Now let us divide both sides by P0A. This component, this part is known as what? This part is known as relative lowering of vapor pressure. So relative lowering of vapor pressure means how much the vapor pressure has been decreased with respect to the vapor pressure of the solvent in its pure form. And this relative lowering of vapor pressure is equals to the mole fraction of the solute. It is quite independent of the nature of the solute, right? So can we say that relative lowering of vapor pressure is a colligative property?
Yes, ma'am.
Ankit, stand up and explain how can we say that relative lowering of vapor pressure is a colligative property?
Ma'am, we know that colligative properties are such properties which depends on the number of solute
particles and not on its nature. Here, as relative lowering of vapor pressure is equal to the mole fraction of the solute, that's why we can say that it's a colligative.
Do you all agree with him? Very good, Ankit. Sit down. So we have finished the first point. The second one is depression in freezing point.
পুষ্টিকর খাদ্য এবং শিক্ষা আমাদের নিতান্ত প্রয়োজনীয় জিনিস।
আপনি কি জানেন বর্তমানে ত্রিপুরায় বিদ্যালয় শিক্ষা দপ্তরের অধীনে মধ্যাহ্ন আহার প্রকল্পের উদ্যোগে সবকটি বিদ্যালয়ে সবজি বাগান গড়ে তোলা হচ্ছে।
ছাত্রছাত্রীদের পুষ্টিকর খাদ্য প্রদান করার লক্ষ্যে সেই বাগানে উৎপাদিত সার এবং কীটনাশকবিহীন সবজি প্রথম থেকে অষ্টম শ্রেণীর শিক্ষার্থীদের মিড ডে মিলে ব্যবহার করা হয়।
চলুন শিক্ষার্থীদের স্বাস্থ্যকর এবং নির্ভেজাল খাদ্য প্রদান ও সুস্থ সমাজ গড়ার লক্ষ্যে আমরা সবাই এগিয়ে আসি এবং প্রত্যেকটি বিদ্যালয়ে সবজি বাগান গড়ে তুলতে বিদ্যালয় কর্তৃপক্ষকে সাহায্য করি।
So next topic of today's class is depression in freezing point. Well, first of all, we need to know what is freezing point, right? Freezing point is the temperature at which the vapor pressure of a volatile solvent in its liquid phase will be equal to the vapor pressure of the same solution in its solid phase. Okay? Now, as the vapor pressure decreases upon the addition of non-volatile solute, the freezing point of solution also decreases. Okay? Let us understand this with the help of a graph. The y-axis of the graph represents vapor pressure. X-axis of the graph represents temperature. The first line is for liquid solvent. That means the pure solvent. It's not solution. It's a pure volatile solvent which is present in its liquid state. Okay? As we decrease the temperature, what happens? Its vapor pressure decreases. Its vapor pressure decreases, and as soon as the temperature reaches T0F, T0F is the temperature at which the vapor pressure of the solvent in the liquid phase will be equal to the vapor pressure of the same solvent in the solid phase. So this is the temperature of the freezing point for that solvent. So as we go below this temperature, below the T0F temperature, you won't get the solvent in the liquid phase. It is written over here. You can see it very clearly that it is frozen solvent, right? That means the solvent in the solid portion. Okay? Now, as the vapor pressure of solution is less than that of the solvent, the second line is for the solution side. So, as the temperature decreases, the vapor pressure decreases. The moment it reaches TF, that is the freezing point for the solution, the vapor pressure of the solution in the liquid state is equal to the vapor pressure of the same liquid in the solid phase. So below this temperature, we will get only the frozen solvent. So this difference in temperature, that is delta TF, is the depression in freezing point. Depression means decrease. How much the freezing point has decreased because of the addition of the non-volatile solute. Is this clear?
Yes.
So let us write it over here. This quantity is known as depression in freezing point, which is proportional to molarity of a liquid. And the proportionality constant is Kf. Kf is the proportionality constant, which is known as depression freezing point constant, molar freezing point constant, or cryoscopic constant. Okay? Now, cryoscopic constant can be defined as the depression of freezing point for a solution whose molarity is 1. That means if we consider a solution of 1 molar, if we are considering a solution solution of 1 molar. 1 molar means, what is molarity? Number of moles of solute present in 1 kg of the solvent. So if we consider the solution to be 1 molar, means if 1 mole of solute is present in 1 kg of the solvent, the cryoscopic constant for such solution will be the depression in freezing point. Okay? Now can anyone tell me what is the aim of colligative property? Tara, stand up and tell.
The aim of colligative property is to find the molar mass of an unknown solute.
Very good. Is to sit down. Is to find the molar mass of an unknown solute. How can we get it? Delta TF equals KF into molarity. Suppose W2 is the weight of the solute present in W1 of the solvent. W1 gram of the solvent, which is in gram. And the molecular weight of this non-volatile solute is M2. But molality says that number of moles present in weight of the solvent in kg, right? So we need to convert this gram into kg. For doing that, what we need to do? We only have to divide this by 1000. Ultimately, it will go to the numerator and it will become it like this. As you can see from here also, right? So when you will rearrange, you will get the molecular weight of the non-volatile solute. This is okay? Now the third topic. Third topic is elevation in boiling point. In smaller classes, we have learnt about boiling point. What is boiling point? The temperature at which a solution starts boiling, right? Now we need to forget the definition. According to the new definition, we don't have to forget the definition. It has only modified. According to the new definition, this is a liquid. This is a volatile solvent confined in a vessel which is covered with a lid. Now it has some vapor also, right? Molecules in the vapor phase. Now outside this lid, what is present? Inside the lid, vapor pressure of this liquid, right? Outside the lid, one more pressure is acting. What is that? Atmospheric pressure. Very good. Atmospheric pressure. Now that the moment this vapor pressure of the solution becomes equal to the atmospheric pressure, the temperature at which it happens, that temperature is the boiling point for this solution. That is the temperature at which the vapor pressure of this solution will be equal to the vapor pressure of the atmosphere is the boiling point for this solution. Is this okay? Now tell me what happens when the same solution will contain some non-volatile solute. The vapor pressure decreases. The vapor pressure will decrease. So in order to equalize the vapor pressure of the solution with that of the atmospheric pressure, what all we need to do? We need to increase the temperature. So how much we are increasing the temperature? That is only elevation in boiling point. Am I clear? Yes. So let us again understand the same concept with the help of a graph. This is vapor pressure. Y-axis represents vapor pressure. X-axis represents temperature. The bar on the y-axis represents the atmospheric pressure. Means the moment the vapor pressure of any solution or solvent reaches that atmospheric pressure, the temperature will be its boiling point. The red one representing the pure solvent. So when you are increasing the temperature, the vapor pressure is increasing, and the temperature at which it touches the atmospheric pressure is the boiling point of the solvent, which is represented as T0B. 0 represents the pure solvent. Now the second line, which is blue in color, this is the vapor pressure for solution, which has non-volatile solute also. So when we increase the temperature, the vapor pressure increases. The moment it reaches that bar, is that the temperature is TB, and it represents the boiling point of the solution. Okay? And how much it has been increased? Delta TB. This delta TB is what? Elevation in boiling point. How much the boiling point has increased due to the presence of the non-volatile solute. So we can write delta TB equals what? TB minus TB0. This equation and the freezing point equation, there is slight difference, right? In case of freezing point, we used to write that TF0 minus TF, because the freezing point used to decrease due to the addition of non-volatile solute. But in this case, it increases. This temperature will be more than that of the solvent, which is again proportional to molality of the solution. And again, we will be having one constant of proportionality. This constant of proportionality is known as molar elevation constant, or boiling point elevation constant, or evoluoscopic constant. Again, if we break the molality, we will get what? The molecular mass of the unknown solute, which is the main aim of studying colligative properties. And what can you define the evoluoscopic constant from here? It is same as cryoscopic constant for a solution with one molality. That means when 1 mole of solute is present in 1 gram of the solvent, Kb, that means the evoluoscopic constant, will be equal to the elevation in boiling point. Okay? Now, one very important topic from this topic is the unit of, to find out the unit of cryoscopic constant and the unit of evoluoscopic constant. Cryoscopic constant, okay, let me write it. Delta TF equals Kf into molality. Kf is cryoscopic constant. So Kf equals delta TF by molality. What is delta TF? Depression in freezing point. It represents temperature. What is SI unit of temperature? SI unit Kelvin. So Kelvin, the unit for molality is mole per kg. So from this we can write unit of, very good, Kelvin, kg, mole inverse. Okay. In the same way, we can find out the unit for evoluoscopic constant also. Evoluoscopic constant comes from where? Elevation in boiling point. Okay. So Kb equals delta Tb upon m. Again, delta Tb represents temperature. Its SI unit is Kelvin. This is molality. Molality's unit is mole per kg. So we will get the unit for Kb as Kelvin, kg, mole inverse. So what we come to know from this two, both the constant, whether it is cryoscopic constant or evoluoscopic constant, both has got the same unit. Okay. Now few important questions which are important from the topics are, how can you prove that relative lowering of vapor pressure is a colligative property? We have already discussed this. In order to answer this, you have to derive the whole equation. The second equation is derive the expression for depression in freezing point, then derive the expression for elevation in boiling point. Means we have to show that how M2, that is the molecular mass of the non-volatile solute, can be found out using the elevation in boiling point and depression in freezing point. Then cryoscopic constant and evoluoscopic constant's definition we have already discussed, and their unit. Okay, so that's all for today's class. In the next class, we shall be discussing or we shall be practicing some numerical problems based on the topics which we have discussed.
Thank you, ma'am.
ড্রপ আউটের ঘুচিয়ে ক্ষত, স্কুলে পড়ুয়ার বাড়ছে ভিড়, সর্বশিক্ষা মিড ডে মিলে স্কুল সকলের আশার নীড়।
রাজ্যের 6 থেকে 14 বছরের সব শিশুদের বিদ্যালয়ের আঙিনায় এনে তাদের বুনিয়াদী শিক্ষা সুনিশ্চিত করতে সর্বশিক্ষা অভিযান বদ্ধপরিকর। তাদের শিক্ষার সুবিধার জন্য রয়েছে বিনামূল্যে পাঠ্য বই, বিদ্যালয়ের পোশাক, উন্নতমানের পড়াশোনা, স্বাস্থ্যসম্মত শৌচাগার, বিশুদ্ধ পানীয় জল, পুষ্টিকর মধ্যাহ্ন আহার, খেলাধুলার ব্যবস্থা এবং আরও অনেক কিছু।
হ্যাঁ, তাই দেরি না করে আজই আপনার এলাকার সব শিশুদের নিকটবর্তী সরকারি বিদ্যালয়ে ভর্তি হতে উৎসাহিত করুন।
E-Classroom was sponsored by রাষ্ট্রীয় মাধ্যমিক শিক্ষা অভিযান ত্রিপুরা রাজ্য মিশন।